So the idea of absolute value. The formal definition of absolute value is this. The absolute value of A is A if A is greater than or equal to 0, but it's negative A if A is less than 0. Hence, you always end up with a positive number, or 0, of course. Basically, absolute value, you can think of it as the distance from 0. That's basically what it is. We're interested in the magnitude or the size of the number. The direction, whether it's positive or negative, we don't care. So some results for working with absolute values. You got to remember, an absolute value, they are actually grouping symbols. The absolute value of negative x will always be the same as the absolute value of x. Because again, we're saying we're not interested in the direction, we're just interested in the size of the number. For that reason, if you go x minus y or y minus x, it doesn't matter. You'll get the same size of the number. One will be negative, one will be positive, but we're just interested in the size. And multiplication, well, it doesn't really matter whether you do the multiplication first, then find the absolute value, or find the absolute value of each individual number, then do the multiplication. You're still going to get the same answer. Similarly with division, right? It doesn't matter which way around you do it. It may sound obvious, but the absolute value of x squared is x squared. This one's more interesting. The square root of x squared, often mistakenly put down as an answer of just x, but it's not. It's the absolute value of x. All right, let's start with a real basic one then. Absolute value of negative 5. How far away is it from 0? Oh, it's 5 units away, so it's 5. As I was saying, they are grouping symbols, and we know we do what's inside the grouping symbol first. So 6 minus 8 minus 2 is negative 4, so the size of that number is 4. Once again, order of operations. We do inside first, so 6 times 3 is 18, minus 20 is negative 2, but the absolute value of negative 2 is 2, so 7 minus 2 is 5. That, of course, means 3 times, just like if we had parentheses there. Again, they are grouping symbols. So we're saying 3 times 6, 18. That brings me to this interesting question. The absolute value of x squared if x is less than 0. And the answer is negative x. If x is a negative number, then when you find the square root of x squared, you can't end up with a negative number because we're saying the positive square root. So it must actually be negative x, the answer there. That's why in that result I put before, we say absolute value of x, and then we don't have that issue. The graph of an absolute value curve. Well, curve, I say, straight line. If we look at y equals the absolute value of mx plus b. So what we basically do is whatever is below the x-axis, we reflect above, because we can't get a negative answer. So anything below bounces and reflects above. So y equals the absolute value of x is our classic V shape. Now, I need to put some sense of scale here. Some people put a right angle symbol because obviously the slope of y equals x is 45 degrees. So there would be a right angle in between the two. I just usually put a couple of points on it, give it some sense of a scale. 1, 1, negative 1, 1. So if we have to sketch the absolute value of x plus 2, so let's combine our basic curve with our translations and so on. So the basic curve is our absolute value curve. So there it is. But we have shifted ours left 2 units. It's grouped with the x because it's inside the grouping symbol. So we get that and we shift it 2 units to the left. And so those points I labelled before, the 1, 1 and the minus 1, 1, well, they've shifted 2 to the left. So they're now minus 3, 1 and minus 1, 1. That's one way of thinking about it. Another way I could think about it is that actually the basic curve, it's not y equals absolute value of x, it's actually the line y equals x plus 2. And I'm going to find the absolute value of it, so therefore whatever is below reflects above. I get the same picture. So there's different ways of thinking about the problem. What about if it's just absolute value of x plus 2, so our basic curve, absolute value of x, but now it's not grouped with the x. So this is a vertical shift we're talking about. So we've shifted it up 2 units. So whoop. So now it's the y values that have changed. Let's move on to solving absolute value equations. I don't know how you've been shown to solve these in the past. It might be what I'm about to show you. It might not be. We'll soon see. It's a very simple one I'm starting with. Absolute value of x equals 7, so intuitively we say, well, okay, we know the answer is plus or minus 7. That's fine for a real simple one. But we get something like this. And the temptation is to simply say, oh, well, that's plus or minus 7. but I don't. I go back to what is the definition of an absolute value. And the absolute value definition said it's either x or minus x, or a or minus a. So in this case, it's either 2x minus 3 or minus 2x minus 3. Now, effectively, it's the same thing, but why think that way? You see, we're dealing with an equation at the moment. If I think this way, then when we start dealing with inequations, I don't end up with any problems. We go and solve each of these. We've got x equals 5 for the first one, and we've got x equals negative 2 for the second one. So my final solution, and the word is or, not and, because it would be impossible for x to equal negative 2 and equal x equals 5 at the same time. So these are two possible solutions. Well, what about this one? Another reason why it's good to think of it with the definition. So now I say, well, either 2x plus 6 is 3x minus 1, or the negative of 2x plus 6 is 3x minus 1. I solve the first one, x equals 7. I solve the second one, x equals negative 1. That is where a lot of people stop and, of course, get the question wrong. Because what don't they do? They don't check their answer. X equals negative 1 is no good. If you go back to the original question, what do? You get the absolute value of something is negative 4. Well, that's impossible. So why did this happen? The reason it happened is because we changed the original question. We changed it to something simpler that we could solve. Now, when you do that in equations, sometimes you create new solutions. It'll be a solution to the new equation that you created, but it might not be a solution to the original question that was asked. This is why we always check our solutions. So x equals negative 1 is not a solution. The only solution to this equation is x equals 7. By the way, when does this situation happen? If you think about it, the only time you're going to get that problem is if you've got an equation which has absolute value equals, and then have to be pronumerals on the other side. If it was absolute value equals absolute value, you're not going to get that problem. And if it's just a number on the other side, you're not going to get that problem. The problem came because of the x, and it might be negative, it might be positive, we don't know. Oh, time.